All right, ladies and gentlemen, we are going to be looking into the beginning part of graphing quadratics. And this is really an introduction where we are not actually graphing, we are just identifying the parts of a graph, which is going to support us as we move towards solving quadratic equations and graphing quadratic equations. Okay, so just to keep us in mind here, that when we have a quadratic, what we are talking about is something to the second power. And so we wrote this over and over again in the last chapter. What is different is that we would just always write ax squared plus bx plus c. Now we're taking that quadratic, which was an expression, and we're moving it into an equation, which means we have this y equals in here. And so now we're going to look at how to solve this and how to graph this. And so quadratic equations, when we graph them, form what is called a curve, and that curve has a special name, which is called a parabola. And you can see that what we have here is a parabola. And this parabola, the ball is kicked and it follows this curve, okay? In this particular one, we call this that the opening opens down, okay? We also have parabolas that look like this, where the opening opens up. And we're going to be able to identify that not only on a graph, but by looking at the quadratic equation that is given to us and being able to determine what the shape looks like. So that's going to be one of our things that we're looking for. Then down here at the bottom are the rest that we're going to be looking for. We're going to be looking for the axis of symmetry. That is going to be the vertical line that separates the parabola into two symmetrical parts. So if we looked at this real quick, what we would be looking for is this line that goes right through here and separates that into two symmetrical parts. We're looking for the x-intercepts. The x-intercepts are the same things that x-intercepts are when we talked about linears. They're the place where our graph crosses over the x-axis. But they also have other names. They could be called roots or solutions or zeros. So for example here, the x-intercepts would occur here and here. We already talked a little bit about the shape. We will then be looking for the vertex. The vertex would be here or here. We would be looking to see if that vertex is a maximum point or the minimum point. So this would be a max. It's the highest point. This would be a minimum. That's the lowest point. And then the other thing I believe we're familiar with already is the y-intercept, the place where our graph crosses the y-axis. So the y-intercept would be here. Over here I didn't draw a coordinate plane, so I can't really determine where the y-intercept is. So this is just an idea of what our goals and objectives are for this particular unit this week. We just want to become comfortable with this vocabulary. And then we also want to make sure that we can, given the vocabulary words, you can find them on the graph, or looking at the graph, you can identify what the parts are using the correct vocabulary. Okay, so let's look at this page, and here we are, the parts of a parabola. Okay, so now we're going to, some of the things that we talked about last time on the last page, we're going to put into play here. Okay, so I'm going to look right here at this point. And this point is the vertex. Okay. Since this parabola is open up, this vertex is also the minimum point. We would also know then from this vertex, if we were to draw this vertical line through here, that would actually be called the axis of symmetry. It takes the parabola and breaks it into two symmetrical parts. I always abbreviate it as the axis of symmetry. And if we look at that, our axis of symmetry here would be the vertical line. Remember, vertical lines are always written as x equals, and so it's x equals 2. And then I don't believe down here that I wrote the vertex point in. So let me go look at that. That is the point 2, -1. Notice how that the x-coordinate of the vertex here is going to be the vertical line here. And that is always going to be true. So once you know the vertex, you know the axis of symmetry. Remember, we know the difference between a point, a single point on the coordinate plane, versus a line, x equals, which is this whole entire line. So we're being careful with notation there also. Okay, let's look a little further of what we have here. What I see here are our x-intercepts. And our x-intercept is at this point here, which is a single point. So I'm going to write that out as 1, 0. And a single point here. So I'm going to write that out as 3, 0. And we use a couple of words interchangeably here. And I'm going to note that so that we get used to using this. Instead of saying what are the x-intercepts, it could say what are the roots of the equation or the roots of the function. It could say, what are the solutions? And we're going to spend a lot of time solving these quadratic equations to find these x-intercepts, to find the solutions. The other thing that they could be called are what are the zeros? And they're called zeros because they're the value of x when y equals 0. So we want to make sure that we get all of those words interchangeably. Okay, so the last thing that they have marked off is over here, which is this point 0, 3, which is the y-intercept. Now, if we look at this parabola, we can see that it's opened up. And that tells me one other piece of information here. We know for several lessons that we have been calling this a value here our leading coefficient. And I told you before that that was going to give us an idea of what our parabola looked like. And we would have to wait to see what was, when we started to learn about that. Well, today is that day. And now what that tells me is since our parabola is open up, that this a value has to be positive. So I'm going to write it that a is greater than 1 or equal to 1. Okay, so basically we know that that a value is positive if our parabola is opened up. So let's start to, and you might want to pause, you might want to write down this on a separate sheet of paper, make sure that you're familiar with the vocabulary and where these things are located. Now we're going to look at some actual examples and be able to pick out these pieces. Okay, so this is your call. At this point, you might want to pause the video and see if you can identify all of these things over here written in blue based on this graph. And if you want to try to do that on your own, then go ahead and pause. And when you're finished, start it back up and check the answers with me. If you're not quite sure yet, just keep on working with me. So if I look at this, the first thing I notice is that the parabola opens up. The opening is at the top. So what that tells me is that it opens up. Oop, I do not want a magic marker there. That it opens up, and you can either write the word up or draw that, but what it's telling us is that A is positive. We don't know the equation yet. We'll get there. Right now we don't know it. We're just looking at these parts, okay? The next thing I want to do is look for my intercept. So here's my x-axis, and I can see that my graph crosses the x-axis here, which would be the point -1, 0, and here, which is the point 3, 0. And those are my x-intercepts. So I'm going to have that at -1, 0, and 3, 0. Okay. All right, so the next thing I'm looking for is the y-intercept. And so if I look at the y-axis, right here is the point where it crosses over the y-axis. And so this is the point 0, -3, and that is our y-intercept. I'm then going to look at these three things kind of go together. So I'm going to look right here, and this is the point 1, -4. That is our vertex, 1, -4. Because the parabola is open up, this is the lowest point, or the minimum value. And now from this vertex, I can draw in this imaginary line, which is the axis of symmetry. And remember, we always write that as a line, and it's going through the x-coordinate of 1. And so all the x values on that line will equal 1. And those are the important parts of this parabola. Now keep in mind, once again, we're not graphing these yet. We are just identifying the important parts so that when we go to solve and graph, we know the vocabulary and we know the locations of these words. Excuse me. All right, so now here we're doing this again. If you want to, if you think you're ready to do it, then pause and answer these questions based on this parabola. If you're not quite ready to do that yet, then just keep working along with me. All right, so when I look at this, the first thing I do see is that it opens up. And so therefore, that tells me that if I were going to look for the equation, that the A value is positive. Okay. This graph is one where we have a little bit of a unique situation, because if I look at this point right here, this point is doing a bunch of different jobs. It is the x-intercept, or the root, or solution, or 0 of the equation. But it's also the place where it crosses on the y-axis. So it is also the y-intercept. It is also the vertex. And since it's open up, it is a minimum point. And it is also going to tell us the axis of symmetry, because if I were to draw this imaginary vertical line through the x-coordinate of the vertex, then this would be the line x equals 0, because every x value on this line would have a value of 0. So you can see that that one point is doing a bunch of different jobs. It's where it crosses the x-axis. It's where it crosses the y-axis. It's the vertex, which makes it the minimum point, and it gives us the x-coordinate of the vertex, which then tells us the axis of symmetry. All right, so once again, same type of thing here. If you're ready to answer the questions on your own or try them on your own, pause the video and answer this, and then turn the video back on to check. If you're not feeling that you're ready yet, then just keep working with me. So if I look at this, I can see that my parabola for this opens up. And so that tells me that A is positive. And you can see that on this particular graph right here, that it's given us the equation, and A is a positive 1. And so we can verify that A is positive and it does open up. Now, when we go to look at our x-axis here, what you might notice is that it never crosses over the x-axis. So we are not going to leave that blank. We're going to actually write that there are none. And when we go to solving, we're going to talk specifically about this particular case where we do not have what appears to be any any crossover on the x-axis. But for right now, we want to write none. We don't want to leave it blank because blank leaves it open to interpretation. Did you not know, or did you know that there isn't any? We don't want to write anything with a 0 because then that might be interpreted as an ordered pair, okay? What I do see, though, is that right here, that there is a y-intercept, and that is at the point 0, 3. So I am going to write that y-intercept in. And then I can see that right here is the vertex, and that is the point -1, 2. And that vertex is on a parabola that is open up, so it is a minimum point. And then that also tells us that if we were to draw our imaginary line, our axis of symmetry, through that vertex, and we remember we always write this as an equation, all the x values on this line would have an x-coordinate of -1. So our axis of symmetry is x equals -1. So as you can see with these examples, I'm trying to give you ones that are have the same general features, but look a little bit different so that we can identify where these parts are. All right, so here's another one. Same rules. If you feel you are confident to go ahead and answer this on your own, go ahead and write that down and do that. Stop the video and check. If you're not, go ahead and just work along with me. So the first thing I notice is that this one opens down, okay? And so what that tells me is that A value is negative. And this graph happens to have the equation here, and you can confirm that the A value is negative. It's -1. Okay, now there's no order in which you need to answer these over here. So as long as you hit all of the things, it's fine. So it might, you might think, well, if A is -1, that might lead you to look for the vertex. And the vertex is at -1, 4. And if the vertex is at -1, 4, since this parabola is now open down, this point right here is the maximum value. And so that's going to be the first time we've seen that as opposed to minimum values. And then we would know that if we know the vertex and we drew this imaginary line called the axis of symmetry through the vertex, And if the x-coordinate of the vertex was -1, that means that every x-coordinate on the axis of symmetry would have to have an x value of -1. Okay. Other points we're looking to identify, if we look right over here, this point right here at the point 0, 3 is our y-intercept. And if we look here, we have a point at -3, 0, and a point at 1, 0, and both of those are our x-intercepts. All right, so this is our last one here. I'd like everyone to stop the video after I give the directions. And there's 2 graphs on here. I would like for you to try to, using this blue parabola right here, try to fill out this information. And then this is a purple one. And either my pencil doesn't do purple or I can't figure out how to do purple. So I wrote it in red, but this is for the purple graph. See if you can figure out this information. And when you have those completed, or you have them done as much as you can, then go ahead and restart the video and check your answers with me. All right, so looking at the blue graph, we can see that it does open up, so therefore that the A must be positive. We can see that we have x-intercepts, and that is going to be at 1, 0 and at 3, 0. We can see that we have a y-intercept, and that is going to be the point 0, 8. If we look here, this is our vertex, which is the point 2, -4. And since that's open up, our vertex is a minimum value. And if we drew our imaginary line through the x-coordinate of the vertex, which is 2, then all of the x-coordinates would have to be equal to 2. And so that is our line representing the axis of symmetry. All right, if we look at the purple graph, we can see that this opens down, and so therefore our A value is going to be negative. Okay. If we look here, this is the point -3, 0. And that point is doing several jobs for us. It is the x-intercept, and it is also the vertex, and since our parabola is open down, it is the max value. And through that vertex, if we were to draw an imaginary line, and since the x-coordinate of the vertex is 3, every x-coordinate on the axis of symmetry must be 3, and so our equation of that line is x equals -3. And then the last thing we're looking for is the y-intercept, which occurs right here, which is the point 0, -6.